All right, so let's start, everyone. Okay, so let's quickly go over what we did last time. So last time we started the new topic. It's the analytic geometry. So we use a method of the XY coordinate system and algebraic method to solve problems in geometry. So that's the idea. Okay, and some of the easy formulas warming up, right? For every 2 points, you can figure out the slope and then how to use that the slope to get the equation of the line, right? So we can get the following. Let's see. So these are the first one is the intercept, slope intercept, point slope formula, right? And then the other one is that suppose we get the two intercept, the x-intercept, y-intercept. How do I get the equation fast? It's x over a plus y over b equals 1. Parallel lines mean that the two slopes are the same. Perpendicular lines mean the product is equal to minus 1, right? And then we have the distance formula, the midpoint formula, right? And this is a good example, right, to show how we can use analytic geometry to solve problems, right? To solve a geometry problem, right? Look at that. So for problems, if you have a rectangle, like if you have a rectangle like that, then usually that's the way to use a natural geometry way to solve that, because the rectangle is very natural to set up the XY coordinate system, right? So like that one, right? So this is a good one, and another one that's also a problem in geometry problem, right? Geometry. So suppose you have a triangle, right? ABC is a triangle, C is a right angle, right? Then CH is perpendicular with BC, and now, so you can see that. So you can say, right. So this is how you can prove this, right? Just do that. Okay. So leave the give everyone a minute. Let's take a look at how we prove this, right? So we want to prove that a CH square is equal to AH times the BH. Okay. Why? The original proof in geometry, in the previous course, we used similar triangles, but now today I don't want to do that. Okay, so let's see. AC, the slope of AC is a negative C over A, right? The slope of AC. And then the slope of BC is a negative C over B, right? And since AC and BC are perpendicular, then I know that the product of the previous two numbers must be equal to negative 1, right? So that must be equal to the negative 1. And then do the substitution, and then we get that. So this is just the same as the CH square is AH times the BH, right? So that's cool. Okay. Now we talk about the 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 circle, right? So we get a circle. If the center has the coordinates of HK, the radius is equal to R. How to write down this equation, right? So it's so this is a typical problem, right? For that kind of question. So this is the equation, right? So this is the equation here. So x minus h, take a square, and plus y minus k, take a square. That's equal to R squared, right? And so here's some example, right? How to write down that. So if I have this equation, I can find the center, I can find the radians. And this one, now this one, we need to pay some attention. It involves the technique of completing the square, right? How to complete the square? Where if you have x squared plus 10x, how to get the 10x? Where 10 is 2 times 5, so I need to add a 5 square, right? 8 is 2 times 4, so I need to add a 4 square. So if I have a 5 square and together with x and together with 10x, that give me a perfect square. So this is the idea for perfect square. So I want that and I want that. So I give everyone 30 seconds to 1 minute. So try to understand the perfect square, right? Complete the square. That's very important. And next one we get here. Suppose we have the AB, and I want to get the equation of the circle with AB as the diameter. And again, that's a typical problem. So if AB is the diameter, you figure out the distance of AB, right? And that's the actually the radians, right? That's the radians. And then you still need to figure out the center. The center is the midpoint formula to get that, right? So we can get this. Okay, and the other one, find the equation. Find that equation where the radians is equal to 2, and you have the center, so you can finish it. You can finish the rest of it, right? Okay, so that's from last time. That is from last time. Are there any questions? Any questions? Okay. Well, let's do a homework. Someone asked a homework, so I can do one of them. So let's try homework maybe 9. Homework 9 is hard. Okay, so this is hard. Okay, so let's do it. Okay, let's try that. So homework, let's do homework 10, question number 9. Okay, homework 10, question number 9. So let's see. I'm gonna do this. Okay, let's do. Okay, and then I'm going to do the. All right, so looks like this is a good picture. Okay, so I'm gonna have my. Let's see. So this is A and B, C, and here's a tangent, tangent FQ, right? And this is X here, and W here. Let's see, what's that? Y, and I got a Z here. Okay, so let me try to understand that. Suppose you have a triangle ABC is equilateral. 9 and AW over AB is, let me write down here, AW over AB is 1 over 6. Okay, AY over AC is 1 over 4. Okay, I want to get the BQ over QC. All right. Okay, so we get a 1 over 6 and 1 over 4, and 6 and 4, the common denominator is equal to 12, right? The common denominator 6 and 4 is equal to 12. So without loss of generality, I think it's better to just assume that we get the AB, BC, and CA is equal to 12. Does it make sense? So, oops, my, wait a second. I think, all right, so my screen didn't get that. Okay, everyone can see my screen now. Very good. Okay, very good. So let's see. Everyone can see my screen. Very good. Excellent. And now, so I just assume that the triangle ABC has a side of 12. Why do I choose 12? Because the ratio here, right? The denominator is 4, and the other one is 4. The other one is 6, and 4 and 6. The common denominator is 12. So that makes things much easier, right? Okay. So let's say so AW is 1 out of 6 of the side. So I can say this is 2, this side is 2, and that side is 3, right? 1 over 4. So I know that one is 2, the other one is a 4 here. So that makes things easy. Okay, let me assume this is x here. So if this is x, then the whole thing is 12. Okay, 12 minus 2, that's 10. So I know that this guy is 10 minus x. Everyone's okay? So I assume that the bx has a length of x. So xw has a length of 10 minus x because the entire thing is 12. Okay, and then similarly I can have this is y, and the entire thing will be 9 minus y because the entire of the BC is equal to 12. 12 minus 3 is equal to 9, right? So 9 minus y, so that's here. So you got all of those kind of stuff here. Okay, now we are going to use the power of point. Okay, we're going to use the power of point. So let's take a look. If I take a look at the power of point at the A, so let's see the power of the point A. So that means I'm going to have 2 times what? 2 times AX. AX is a 2 plus 10 minus X, right? So that's one side. Can you see that? So it is, just remind you, so it's this number, right? This side times the other side, right? So that's a definition of the power point if the point is outside of the circle. Okay. And then the other one, the same thing, 3 times 3 plus 9 minus y. Okay, so this is one way to do that. Okay, right? Does it make sense? Right? Okay. But now, so that's one thing. But now there's another thing, another equation. So I get the one equation here, but I need another equation. What is another equation? Well, if I look at the power of a power of b, let's see what happens. So let's see the power of b. Then I can have the bq square is equal to the x times the x plus the 10 minus x. Can you see that? So this is another one, right? So this is the power of b. So it's a bq square, and then the other one will be this number times the other number here. Does it make sense? Right? Okay, so I'm gonna don't confuse you, right? So that is equal to 10 times x. And therefore, the BQ, so this implies that BQ is equal to square root of the 10x. All right, so this part is the square root of the 10x. Okay. Similarly, if you work on the power of C, you're going to get the CQ is equal to y times y plus 9 minus y. So that's a 9y. This implies that the CQ is 9y take a square root. So this part is 9y take a square root. Okay, now we are almost done. Why we are almost done? I just need one more equation. So if I have one more equation, then I'm going to have, well, let's see the sum of that. What's the sum of this? So if you have the BC, well, from one side, I know the answer is 12, okay? But from the other side, the answer is the square root of the 10x plus the square root of the 9y. Okay, we got two equations. Here's one equation, here's another equation. And then I just leave the work to you. So after you solve the equation, it's a little bit complicated, but we can get the answer. So the x, so solve this equation, okay? Solve this equation. X is equal to 106 minus 12 times the root of the 70. Okay. And then you can get the rest of it. All right. So if you get an X value, you can get the Y value, right? You can get the Y and you can get everything. So the final answer, again, it's a little bit tedious because it involves the square root of something. So it's not the easy computation. So the final answer should be 2 root of the 270. Square root of 70 minus 5 and divide by 17. So that's my answer here. Okay. Anyway, so you need to double check here. Okay, you need to double check here. All right, everyone's good. Okay. All right. So this is from the homework. From homework. Now let me just give you some problem here for today. Mm. So today I'm going to give you some more problems involving the circle, especially for the tangent line. Okay, we need to work for the tangent line. Okay, so let's see. Find. Let's see. I'm going to have. Here's the equation. Okay, let's see. Okay. How could I get the right one? I think I want this. Okay. So let's see. All right. So you get suppose this is a equation, and this is a circle for x minus 4 square and y minus 3 square. That's equal to 36. All right. So that means the center is somewhere. I don't know. So somewhere here. So this is a 4, and the other one here, that's a 3 here. So that's the center here. Okay. And then you get the tangent. No, you get the intersection point. So you get the A and B, right? And I want to figure out, I want to find the equation. So I want to find the equation. I want to find the equation for the line of AB. Okay, so let's see. Everyone get that answer? All right, so let's see. I'm going to get here and then maybe just pass through this one here. All right, so I want to find that. Oops, that's not what I want. All right, so I want to get that. And well, the basic idea is that how do you find the x-intercept? How do you find the y-intercept? Right? I want to get the x-intercept. I want to find the y-intercept. So let's see. How do you find the x-intercept? Where to get to find the x-intercept. I need to set y equals 0. Why? Because for the x-intercept for the b here, right? B, let's say, here you get x here and y is equal to 0. So y is always equal to 0 if you want to find x-intercept. Right, so let's x equal to 0. So you got the 0 minus the 4, take a square. And then y minus 3, take a square, 36. All right, so that means y minus 3, take a square. And now you can get 36 minus 6 times 4 times 4 is 16. So that's equal to 20 here. Okay. And then I can get what's the y value? Wait a second. I did the opposite way. I did the opposite way. So let me just switch it that way. I get let's see. I did the opposite way. So I'm going to set, I actually set x equal to 0. Okay, we're going to do that later. So x here, I'm going to find y-intercept. Okay, so that means I will have y minus 3. I will have the square root of 20. That's 2 root of 5. right? 2 root of 5. Okay, so I get, so I get my answer is, let's say y is 3 plus 2 times root of 5. Okay, let's see, is that correct? Yeah, so, right, okay, right, so we can get that. Okay. So actually, you should have two solutions because there's another y-intercept is here, right? There's another y-intercept is here. There's another one here. But since we're a is already fixed, a is given already, so I actually choose the positive side, right? The other one, this number here is actually it's actually the 3 minus the 2 times root of 5. But I'm not interested in that because I have an a on the top here. Does it make sense? Right? And similarly, if you do the other one here, so let's see, to find the x-intercept, I'm going to set my y equals 0. Okay, so it's a x minus 4, take a square, and then 0 minus 3, take a square, 36. Okay, let me quickly do that. I think many of you can do this, right? So I can have x minus 4 is 36 minus 9, take a square root. So that is 27, and that's a 3 root of 3. Okay, and so I get my x value. X value is 4 plus 3 root of 3. Okay, I'm a little bit faster just because many of you are easy, right? Many of you, you can do that, right? So after we get that, then how could I get the equation for the 9 of AB, right? The 9 of AB, the equation is that I'm going to have x over the x-intercept, y over the y-intercept equals 1, right? So what's my x-intercept? The x-intercept, according to what I just did here, is just 4 plus 4 plus 3 root of 3. And the y-intercept, according to what we just did, it's 3 plus 2 root of 5. So this is the equation. All right, I want to give everyone some time. So it's not hard. It's just a little bit tedious, right? It's just a little bit tedious. Everyone's good? Okay. Okay, so let's see the next question. So here's the example. Okay, so and let's say a circle has the center at -7, -3. So -3, 5, and passes through a given point, which is -7 and 4. Okay, and I want to find the equation of the circle. The equation of the circle. Okay, so let's try this. We know the center, right? We know the center, and also pass through one point. Okay, so let's see. Right? And so I know that the center is here, right? Oops, okay. That's the center. I get -3, 5. And then it also passed through a given point, right? -3, 5. And pass through a given point, right? Okay. So let's see. Pass through a given point, -7 and 4 somewhere. So let me put that here. So -3. So that's a p here, right? And how do you find the equation of this circle? How do you find the equation of this circle? Okay, give everyone 20 seconds. So I know the center, and I just need to know the radians, right? I just need to know the radians. Okay. So suppose this is O here. This is O here. I just need to figure out the OP, right? What's the square of the OP? The square of the OP, where so P is negative 7, 4, right? So I can just have the difference of the X, right? Take a square, and then the difference of Y, take a square, right? I just need the square of the radians. So the first one is a 4 square. The second one is a 1 square. Everyone is good? That's a distance formula, right? To figure out the OP. So we can get the 16 plus 1, that's equal to 17. And now we are ready to give you the equation. Okay, what's the equation? What is the equation? What is the equation? And the equation is, so we are going to get the x plus 3, right? This is from here, but you take the opposite of the sign, right? And plus y minus 5 and take the square, so 5 is here, and equals the 17. 17 is actually r squared. So let me add one more step here. So that's equal to the r squared. R squared in this case is equal to 17. Right, so this is our equation. Everything's good? Everything's good. Excellent. All right, so the main part for today is I wanted to figure out how to find the tangent line. How to find the tangent line. Okay, how to find the tangent line. So let's see the next question. All right, I need to work for the tangent line. Here's the example. Okay, find equation of the line that is tangent to the circle. Tangent to the circle, which is x minus 2 square, and then plus y plus 1 square equals 10. At the point, at the point, at the point is to the p, which is 3, negative 4. All right, so let's take a look why I'm drawing the picture. Okay. Okay. Oops, something was wrong. Okay, so you have the circle here, all right? And let's assume that the point is 2 and negative 1. So this is 2, this is 2, and this is negative 1, right? So 2 and negative 1. And the radius is square root of 10. Okay. And then I have a point, and let's say the point is 4, negative, 3, negative 4. So here I get a point here, right? This is a point. So this is a 3 point P, 3, negative 4. And I want to find the tangent line going through that point. How do I get that tangent line? Okay, so let's see. All right, so let's see how I can do this. All right, I got a tangent line here. How could I get that tangent line? Does it make sense? Right, so let's see. You get the uh, you get the point of, so let's say this is a O here. It's a little bit confused because usually people use O for the orange, but also people use O for the center of the of the circle. I don't know. Anyway, so let me just use O for the center of the circle, and I don't mention the orange. We don't need the orange, so it's okay. So it's okay. So let's see. All right, so we can get that, and then I'm going to connect the OP, right? And let's call that the B here. So we know that the OP is perpendicular with the BP, right? That's a requirement here. Okay, so how do I find the slope of OP? Where the slope of OP is decided by the slope of the O, the point of O and the point of P, right? So O, you got 2, -1. So I'm going to first get the slope of OP, right? Why do I need that? Because I need a slope of the tangent line, right? Okay, so let's work on that. So we can get the difference of y. That's -4 minus 1 and 3 minus 2. So I can get the denominator is 1, numerator is -3. So I can get -3. Okay, everyone understand that? So first of all, I want to get the OP. The slope of OP, I can get that. If I can get slope of OP, then I can get the slope of BP. All right, so what's the slope of BP? Well, that's the product of the two of them is -1. So if one slope is -3, the other one is a -3, right? The reason is the two of them is equal to -1. So that's the reason. All right, I can get that. And now I can figure out the tangent line immediately. Why? Because I have the point slope formula. So we can get the point slope formula, right? I can get that. So that equation is y minus y1 equals the slope x minus x1. Okay. And then you can just simplify that, right? You can just simplify that. So this is a 1 over 3x minus 1. Y is equal to 1 over 3x minus 1 and minus 4. So it's 1 over 3x minus 5. And that's my answer. Okay, give everyone a minute. Give everyone a minute. Is that good? Okay, give everyone a minute so we get the answer. Any question? Are there any questions? Any question? Right? So this is a tangent. How to get the tangent line? Okay. How to get the tangent line, right? So, all right. So I'm going to give you some more examples involving the tangent line. Okay. Okay. Next question. We're going to work on the tangent line. Okay. So again, let me write down the question first. Okay. Suppose that a circle has the center at 2, -3, okay, and is tangent to the line with equation of 4x plus 1. Okay, I want to find the equation of the circle. So this is the opposite of the previous question, right? If you look at the previous question, we give you the circle and we want you to find the tangent line, right? But now it's the opposite. Suppose I give the tangent line and I want to find the equation of the circle. Can you see that? So they're actually related, right? They're actually related, right? Right. Right. Okay. So let's see. I'm gonna draw the picture. Let's see how to do that. Oops, it's not good. Oh no, it's can't do it. Let's do it again. Okay. Mm, no, that's not good. Okay. So we get a point here. So this is the center of the of that. So let me call that B here. So that's a 2, -3, right? And then you have a point, which is the, let's say negative, this is 1 here. Let's see, here is a 1. You get a point of 1. This is A, so that's it. A is 0, 1 here. Okay, and I need to get the, all right, so everyone get that? So you have the, so this is a 9 of y equals a 4x plus 1, and y-intercept is equal to 1, right? And you know the center of the circle is at the 2, 3. And you need to figure out what's the equation of that circle. Okay? Right, so it's opposite of the previous one. Very good. Everything's good? Okay, how do I do that? Well, it's quite similar. So first of all, you know that you get a P here, P is a tangent point, right? And then let me connect the P with the center. Let me call that B here, right? So for the first 9, the slope is 4, right? So just because the slope of AP is equal to 4, 4 is from here. So I know that the slope of BP is negative 1 over 4. Again, just because the product of them is equal to -1. All right. And so I can figure out the equation of BP. The equation of the BP is y minus -3 equals -1 over 4 x minus 2. Does it make sense? Right? And then I can just simplify that. So I can have y is equal to -1 over 4x. And then times that, it's a positive 1 over 2 and minus 3 to the other side. So it's a y equals -1 over 4x and minus 2 and 2 half. So this is the equation for the BP. Okay, maybe I should let's connect that. No, I have the. Wait a second. Let me just use that one. That looks better because yeah. So let's do this one, right? So this is the equation here, right? But now, how do you find the p here? P is here. That's the p here, right? So to find the p, I'm going to find the p, right? Find the p, where p satisfy the two equations, right? P satisfy the two equations. The first equation is y equals 4x plus 1. The second equation is y is equal to negative 1 over 4x minus 2.5. Can you see that? So how to find the p? Where p is just the intersection of the two perpendicular lines. And you can solve that, okay? So I'm going to just quickly work on that because I don't want to spend too much time in just do the arithmetic, do the, right? So after you solve that, if my uh, if my work is correct, so after that, your x value should be, I skip that, but you should check that by yourself. Negative 14 over 17, and y is equal to negative 39 over 17. So that's a point for that p here. Okay, now let's answer the question. The question is that I want to figure out the equation of this circle. So what's the equation of this circle? What's the equation of this circle? Where the center is 2 and negative 3, right? So that's a, because of center, so I can have the negative 2 and 3, right, to the left. And the right-hand side will be the distance, the square of the distance of BP. So it will be BP, take a square. All right, we know the B, we know the P. And so that is the X will be 2, right? You go from that 2 and this X value here, right? So it will be the 2 minus 14 over 7, take a square. Oops, what happened here? Take a square and plus, and then for the y value will be negative 3 minus 39 over 17 and take a square, right? All right. And then we are done, right? So you need to simplify that. But anyway, you don't have to because the right-hand side is very tedious. But that's the idea, right? So let me give everyone one more minute. So what's the question here? The question is that I give you a tangent line, and I tell you the center of the circle, and I want to find the area. I want to find the equation of that the circle. How to find the equation of that circle, right? How do you find the equation of that circle, right? That is this. Everyone is good? Okay, again, I skipped the details. It's very tedious, so I just don't want to go to too much detail. And so the next question, let me do another example for you, okay? The other example, again, it's for the tangent line, but now I want to find the equation of the tangent by using a different way, okay? For the previous one here, for the, let's just take a look. So this is a question, right? You want to find, how do you get that? You want to find the equation of the tangent line by taking the tangent point first, right? You can get the tangent point first, right? And, but, right? The only problem is that you know the tangent point. So you know the OP, and then you know the slope of the tangent line. But what happens if you don't know the tangent point, right? And so that's my next question. Okay, so that's my next question. All right. All right, so that's here is a question. Find the equation. Find the equation of the line through a given point. Through a given point. Let me call that B, is 0 and 6 and 1/4, and tangent, and it is tangent to the circle of x squared plus y squared equals 5 squared. Okay, so this is a little bit hard, okay, because you don't know the tangent point, okay, the tangent point was not given. So let's see how we can do this. Okay, give everyone some time. I'm drawing the picture. So you get this basically is a 5 here, right? 5 here. And then I give an extra point, which is 6 something. So maybe a little bit high here. That's a 6. And so this is a 6 and 1/4, right? And I want to find the tangent to the 9. Actually, you can have two answers, two solutions. Does it make sense? Because when you do the tangent, you have the tangent to the left and also tangent to the right. Does it make sense? Right. But let me just do one of this. So to save me some time, let's do the tangent. Wait a second. Oops. Okay. So let's see. So here's the tangent 9 here. Right? You get one tangent 9, and you should get the other tangent 9. That's a similar idea. Okay. Like that. But let's just do one of them because the two of them are quite similar. So I'm going to do the, let's say, suppose this is O here, and this is my A, and this is my B here. Okay. And this is a tangent point. But the problem is that I do not have the tangent point, right? I don't know this. So I do not know this. Okay. So this is the perpendicular line. Everything's good, right? You get that picture here. So let's see. How do I get the point P? Right? I need to find the point P here, right? Okay. So I know that the P x y. So P x y should satisfies satisfy the following two equations, right? One equation is y equals kx plus 6 and 1/2. This is somewhere here, right? So y is on the tangent line. The tangent line is y equals kx plus 6 and 1/4, right? That's one equation. There's another equation. Another equation is that it's a circle. It's a x squared plus y squared and equals 5 squared. So this is a circle. Does it make sense? So the tangent line is on the circle and is also on the tangent line. So I can set up the two equations. Okay, but k will be decided later. I don't know the k yet. Okay, I don't know the k yet. So let's do the substitution. Right, let's do the substitution. So do the substitution. I can get x squared plus y squared, but y can be replaced by kx plus 4. I can write 6 1/4. That's a 25/4. Right, take a square equals 25. Okay, very good. So now we have, let's see, x squared plus k squared x squared, and then the 2ab. So 25/2 kx, and then we have the 4, 25/4, take a square, that's equal to 25. Okay, and then I'm going to put that together. Okay, I'm going to put that together. So to put that together, the x squared term will be the 1 plus k squared and take a square term. So that together, right, put them together. And then the next one will be 25 over 2k. That's the x term. And then the constant term will be 625 over 16 minus 25. So it's a 16, 25 times 16. That's equal to 0. Okay. That number is 16 here. 25 times 16 is 400, right? So 625 minus 400 is actually 225. Okay. Now, the next one is tricky. The next one is tricky. We get the equation, right? We get the quadratic equation. We can solve the quadratic equation. But if we solve the quadratic equation, most likely we're going to have two solutions for x. But that's not right. Because if you look at the p here, ignore the other one here. If it's a tangent line, if you have a tangent line intersect a circle, the point is a unique point. You have only one solution. So that means this equation has one solution, has exactly one solution. Well, how do I know a quadratic equation has one solution? That means the determinant is equal to 0. So that's the tricky thing here. This one has one solution because it's tangent, right? It's tangent. So that means that the determinant theta is equal to 25 over 2k, that's square, minus 4ac. 4ac, 225 over that, that's equal to 0. And then you can solve for the k here. Okay, let me repeat that. So what's going on here? The tricky thing is that if you have, okay, the tricky thing is that, so the idea is that if you have a circle, all right, and then you end with that one you solve this equation. There are two solutions, all right. And if you have a circle, right, and then you have a tangent line. Let's see, you got a tangent line like that, and then this one has exactly one solution. That's the idea. Okay, but how do I know you have one solution where the determinant is equal to 0? All right, so after you simplify that, I don't have enough time to do all of the, well, I can do that, I guess. Let's try that. Not bad, actually, not bad. So let's just multiply. So let's say I'm going to have this one cancel with the 4 here. Let's just multiply by 4, multiplying by 4, right? So the left-hand side will be 25, take a square, 625, take a k square, minus, I can get is 225 times 1 minus 225 times the k square equals 0. So you are going to get the 400 k square equals 225. And that means your k square should be plus or minus the square root of 225 over 400. So that's a plus or minus 15 over 20. So that's actually plus or minus 3 over 4. So that gives me the answer. Okay, so what's the answer here? The answer basically says that, so let's see. The answer basically says that, where is my tangent line? The tangent line is here. Can you see that? So that's my tangent line. My tangent line is here, so that gives me y equals k. But what's the k here? K is a plus or minus 3 over 4x, and plus 6 and 1 quarter. So this is my, right? This is my answer. Can you see that? Right. So why there are two answers? Because you go from P, you go from B, and you draw the tangent line. You have two different tangent lines, right? One has a negative slope, the other one has a positive slope. But the two slopes, they are opposite of each other. Okay, so I'm going to give everyone a minute. Okay. All right, and as a byproduct, you can find the p, right? So that's the first part of that. Second part is that find find the p, find the coordinates of p. Where how do you do that? Where you have two equations. Here's one equation in that way. The other equation is this way, right? So just plug into the equation. You can get the x squared plus the y. Y is just a plus or minus 3 over 4x plus 6 and a quarter, right? That's equal to 25. And if you solve this equation, again, it's a little bit tedious. Okay, I'm gonna just give you the answer. So I assume everyone can solve that, right? This is just a quadratic equation. So if you solve this equation, you got x value is equal to plus or minus 3, and y value is equal to 4. So there are two answers. Why there are two answers? Because one is here, the other one is there, right? So the answers are 3 and 4, that's here, and the other part is a negative 3 and 4. So that's how you get the tangent line and how you get the tangent point. All right, let me summarize here. So to get the tangent line, you're going to use the determinant. Determinant is equal to 0, so that this is only one solution, right? That's a very tricky part. Okay, give everyone some time. Well, let's see. So far, it's very tedious, right? And some people don't like that. But I would suggest, even if you don't like that, you still have to work that because for some of the problems, the the this kind of method is actually very useful. Okay, this is actually very useful. So so I'm gonna give you one more example from a geometry point of view. So let's see. So here's the example. Let's see. So well, we know that one problem. We know this some time ago, right? So let me just show the picture here. So we know, right? Some time ago, and we get and all right. So we can get that. All right. So some time ago, we say that suppose I have AB, right? AB is the diameter of the circle, and C is just any of the point, right? So we can get that. Let's see. Let's see. All right, so we can get that, right? And so sometimes ago, we know that, and I want you to prove, so AB is the diameter. AB is the diameter, right? Oh, that's too big. Okay, anyway, so let's, okay, so let's see. So AB is the diameter, right? So AB is a diameter. And I want you to prove that the AC is perpendicular with BC, right? Some time ago we proved that. And we can prove by using the pure geometrical method to do that, right? We have actually two ways to do that. But today I'm going to use a different way. I'm going to use the analytic geometry. So I'm going to set up the XY coordinates in this way. All right. So if I set up XY coordinates in this way, that means R. So I'm going to have the A and B. So R. So this is R0. Is just a radius, right? R. So what's the A here? A is just negative R and 0, right? What's the C here? C is doesn't matter. I just call that A and B, right? But A and B should satisfy this equation. So that's A squared plus the B squared, and that's equal to the R squared. Does it make sense? Right? If you pick a point, C from the circle, and that C, the coordinates of C should satisfy the equation. What's the equation? The equation we got here is the, oops, I don't want that. Okay. All right, so the equation I get that here is x squared plus the y squared equals r squared. Does it make sense? Right? So that means A and B must satisfy this equation. A squared plus B squared equals R squared. Okay. How do I show the two sides are perpendicular? Think of that. How do I show that? Give everyone 30 seconds. That should be very easy. How do you show that the two lines are perpendicular? You're going to use the slope, right? So just need to make sure that the slope of that is equal to product of that is equal to -1. Okay, so I'm going to get the slope of AC and slope of the BC. So the slope of AC, it's a B minus 0, right? You get the point from here and the point from there. So it's a B minus 0 and an A minus R. So it's a B over A plus R. Okay, what's the other one? The other one, I get a point here. So I get the B minus 0 and I get the A minus R. So I get the B over A minus R. Right? So far, so good. Okay. So I'm going to just multiply them together. So I'm going to have MAC times MBC. I get the B over A plus R and the B over A minus R. Okay. So the denominator is just a different squares formula, right? So A plus R, A minus R. So I get A squared minus R squared. Oh, now I can get from here. So just because we have this, I can have, what is the A squared minus R squared? Well, A squared minus R squared is equal to negative B squared, right? Is equal to negative B squared. And so that gives me the -1. And therefore, that implies that the AC is perpendicular with the BC. So that's cool. Can you see that? Right? So there are many geometry theorems that can be proved very easily by just using, you set up the XY coordinate system. Okay, so I'm going to give everyone 1 more minute for this question. Right, so it's a very nice proof, right? You don't have to use, the other geometric theorem to do this, right? And you can just set up the XY coordinate system and you can check this. Okay. And I'm going to give you one more example for today and let you go. I hope I just running out of time. I don't have time here. So let's see. Let me do the next one here. So the next one does not involve the circle, uh, but it's very interesting. Okay. All right. So I'm going to have let's see. I'm going to have a I'm going to draw a parallelogram. Okay. I'm going to draw a parallelogram. Right. So this is a parallelogram, right? Okay. So let's see. And I have the diagonal. Oops, that's not right. Oh, I don't have time. Anyway, so let's see. I can just give the problems and to show you how to do it next time. That's very bad. What happened here? Okay. Okay. All right. So let me just give you the problem. So I have the A, B, C, D. All right. So given that A, B, CD is a parallelogram, okay? And I want you to prove the following. So it's a AB square plus BC square, CD square, and DA square. That's equal to the sum of the squares for the diagonal. That's cool. So let's see, you get this one. AC and BD. Right. So for any parallelogram, the left-hand side is the sum of the squares for all of the four sides, A, B, B, C, C, D, and D, N. The right-hand side is the sum of the squares for the diagonals. And it shows that the two of them are the same. Okay, if you want to use the pure geometrical method, you can still do it, but it's not that easy. You have to use basically it's the congruent triangle, and have some techniques to work on that. But if you set up the XY coordinate system, you can just do it very, very fast. So how do I do that? I'm going to just give you the idea, and we can maybe do that the next time. So I can do that 0, 0, right? This is 0, this is A 0, right? So the length of that is A, right? And how about C? C the BC, and then the B, you have the B, you should add the A and then the C here. Can you see that? Because B and C are BC are horizontal lines. So if it's a horizontal line, that means the Y value must be the same. Okay, the X value must differ by A, right? So that's how they can get the parallelogram. So you set up the XY system in this way, and then you just check the distance formula. Just check that, and you can get it. Okay, you can get it. Anyway, so I'm running out of time. I have another class immediately afterwards. I have to stop here. So that's all for today, and see you next time. Okay. So yeah, lots of work, and you have to show the details. Okay. I skip lots of details just because we don't have enough time to do all of this, but you have to finish the rest of it. Okay. So that's all. Okay, I'm gonna see you next time. Bye, everyone.
Bye.
Thank you.
Bye. Thank you.
You're very welcome.